Question 4, we've got a height survey. Adult men from country A found that the heights were normally distributed with a mean of 175.4 and a standard deviation of 6.8. Find the proportion of these men that are taller than 180. Well, I always think in these questions it's worthwhile just drawing out the distribution. It doesn't take a moment, and you can very quickly put the values onto that distribution. So here's a sketch of the normal distribution, 175.4 the mean, 180 the value that we're given to find the proportion of men taller than 180, which means we're going to be looking at this area here. And I've put on the standard deviation of 6.8, both sides away from the mean of 175.4. Okay, the proportion of men taller than 180. This is a normal distribution, so 180 will be our lower limit, 999 will be our upper limit. We've got a standard deviation here of 6.8 and a mean of 175.4. Put all of those parameters into a calculator and you get the proportion of people greater than 180 is equal to 0.24937, or in percentage terms, this is 24.9%, and that is to 3 significant figures. And that's the answer to part A. Now in part B, we're bringing in region B of the country. So let's label this result up as region A. And a student is claiming that the mean height of adult men from region B of this country was different from the established mean we've got here for region A. Random sample of 52 adult men from region B was taken and the mean height was found to be 177.2, which is indeed different from the mean that we've got for region A. One assumption that's being made is that the standard deviation of the heights was 6.8 for both regions, so sigma remains 6.8. So we're doing a hypothesis test on this claim. We need to state the hypothesis clearly and use a 5% significance level. Okay, well, because the word different from is being used, we've got a two-tailed test, which, given the 5% significance level that we're quoting to, which means we're looking for a 2.5 significance level at either tail. So what's our initial hypothesis? Well, the initial hypothesis is that the mean remains the same. So our initial hypothesis is that mu is equal to 175.4. The new hypothesis is that mu is not equal to 175.4. So we've got to start from the assumption that the null hypothesis is true. So our distribution of adult men in region B will have to be this. Let's say it's a different distribution, but they're distributed normally with a mean of 175.4. Now the standard deviation is 6.8, but because we've only got a sample of 52, we have to divide this by 52. So that's now going to be the distribution we're going to be testing the hypothesis on. So we need to find the probability of finding an adult male whose height is greater than 177.2, up to, of course, the very high limit, with the new variance here and a mean of 175.4. So our new standard deviation will be the square root of 6.8 squared over 52. And this turns out to be 0.9429. So popping this into the calculator using the normal cumulative distribution, you get an answer of that the probability is 0.02814. And as I said before, because we're looking for a 2.5% significance level at either tail, this results in a probability of 0.025. And as 0.028 is greater than 0.025, we can reject the hypothesis and that the mean stays at 175.4. There's not enough evidence to change it. So in part C, we've been asked to find the real probability value for the test in part B. Well, the probability we got at either of the tails is 0.2814. So we've got to multiply this answer by 2, and that will be the probability of being in those tails. And this comes to 0.0562. And on it goes. And that's the answer for part C.